When you see this condition, the reflection shows it's past the fixed point, so it's the fixed point minus 20. Okay, then it also says that at infinity, y equals 8x. Oh, where will minus 20 be located? Right, minus 20 must be on the directrix. So now let's draw one here. This is x equals minus 2. The other one is f, where f is 20. This point is minus 20. We'll call it point Q. Point Q is minus 20. Alright, so let's look at this together. Then it says, this passes through point Q, and it intersects this side at 2 points. Okay, so it says that FA equals twice FB. From the graph, we can let this be A, right? Because FA should be longer. Good, this one is FB. So here we know if you have AF and BF, they must be perpendicular. This part emphasizes how to focus on the distance to the directrix. We can draw perpendicular lines. Draw M perpendicular to our directrix. Okay, draw BN perpendicular to the directrix. These are all standard operations. Whether it's a parabola or a direct parabola problem, you need perpendicular lines. You need to use the definitions. Okay, so this part is our M, this part is N. We know that FA equals 2 times FB. What should M equal in terms of BN? M should also equal 2 times BN, right? Because FA equals M and FB equals BN. No problem. So this part will also be doubled. If there's a factor of 2 relationship, if BN is K, then this should be 2K. Are these two triangles, MQ and BNQ, similar? Yes, they are similar. What is the similarity ratio? The similarity ratio means MQ should be larger, right? 2 to 1. So at this point, AQ should equal 2 times BQ. Or 2 times AB, right? This means point B is the endpoint of AQ. Since this is similar, you can think of it as BN, the median of triangle MQ, right? So EN is equivalent to that. The endpoint of QM is B, which should be the endpoint of QI. That makes sense too. So in this case, how do we transform it? Now FA equals 2 times FB. Okay, so what else can our FA equal? What else is twice of what? FA actually equals 2 times OB. Let's connect OB, which is equivalent to point B, the endpoint of AQ. Point O is the endpoint of FQ, right? The endpoints create the median line. No problem, so FA equals 2 times OB. So FA equals 2 times OB. And since FA equals 2 times FB, then we can conclude that FB equals OB. If FB equals OB, then point B must be on the perpendicular bisector of F. Good, so we know that F is at 2, 0. In this case, our origin is at 0, 0. The x-coordinate of point B must exist. The x-coordinate of point B should be the midpoint of 0 and 2. So it should be 1, right? The average is 1. For the y-coordinate, we substitute into y2 equals sine 8x. So point B should be where y2 equals sine 8x, which means y2 equals sine 8. We know this point is above the x-axis, so y should be 22. Therefore, B is at 1, 22. Now we have coordinates for point B and point Q, so we can find K. In this case, the coordinates of point Q are -2, 0. So we now have K. The answer should equal 22. And then comparing with 11, 2, it should be 3, so the answer is 4.